Question 2, B. Yeah. So this question, well, I want you to integrate again, but it is a difference between two expressions. So I wouldn't suggest that you're gonna integrate by each, because it's more difficult. But so what I'm gonna do is this equals to sine 2nx sine x minus sine, that will be 2 n minus 1 x over sine x, right? So the next step is we're going to do sine 2nx minus, I should make this longer, sine 2nx minus, that'll be 2x. Okay, so we got this, this is one of those sums to product rule that sine c minus sine d equals to 2 cos c plus d over 2 sine c minus d over 2. Right, so we've got sine right, so this will be 2 cos c plus d, which is 4nx minus 2x about 2, and sine, that'll be just 2x over 2 over sine x. So we've got 2 cos 2nx minus x sine x over sine x. So that's just 2 cos, sorry, I forgot to add dx here. dx. This will just be that. So to make this easier, I'm going to do u substitution. I'm going to say that this is u. So du will be 2n minus 1 dx, correct? So let me just rewrite this. So this is 2 cos u, wait, sorry. So du equals to 2n minus 1 times dx. That means if I want to differentiate this, I have to, if I want to write this in terms of du, I have to do this. So that will be 2n minus 1 over 2n minus 1. So now we can see that 2n minus 1 dx is here, 2n minus 1 dx. So we can replace that, substitute that by pi over 2, 0, then 2 over 2n minus 1. Sorry, that should be cos here. Cos u du. So now we're just going to differentiate this u function. So that's very easy, because if we're going to not differentiate, integrate. If we're to differentiate the sine x, it's just cos x. So if we're going to integrate the cos x, it's sine x. So if we're going to integrate a cos u, it's just going to be just going to be sine u. And this will still be here, right? And the final answer? Wait, no, the final answer yet. So sine u, and what was u? What is u equal to? 2nx minus x. So that's 2nx minus x. So the question was, oh right, we're going to evaluate this between pi over 2 and 0. Pi over 2 and 0. So we've got sine two n minus 1. Yeah, that's 2n minus 1x. So that 2n minus 1 times pi over 2. Then minus 2. They just sine, yeah, they just sine 0. Sine 0, so that's just 0, so everything is cancelled here. So now we've got, so what they want us to prove this. How do we get that? We're gonna look at this thing. So when n is 1, this part is going to be pi over 2. So sine 2n minus 1 pi over 2 will be 1. Yeah, 1. So if n is 2, it'll be minus 1 because it's 3 pi over 2. And that is, I'm pretty sure that is minus 1. When it is 3, there will be 5 pi minus 2. So, yeah, that'll be 5 pi minus 2. No, not 5 pi over 2, sorry, that's 1. So which means, if I do minus 1 to the power of n, minus 1, it'll give me this number, right? When n is 1, minus 1 to the power of 0, it's 1. 2, minus 1 to the power of 1, so minus 1. When it's 3, it's going to be minus 1 to the power of 2. And that's going to be 1. So that would be 2 and 1 times minus 1 n plus 1. So that's just, check the answer. No, check the proof. Yep. That's the whole process. Right, thank you for watching.